Hello, I'm Michael McCartney, a graduate student at Morningside College and a special education teacher at Smart Intermediate High School in Davenport, Iowa. I studied the effects of formative assessments and feedback on sixth grade math achievement in a Title I school. Currently, general trends of mathematical performance have been improving in America, but there continues to be substantial gaps in that mathematical proficiency for most students across America. According to the 2017 National Assessment of Educational Progress, 66% of eighth graders that were assessed scored below our basic level of mathematical proficiency. When individuals lack poor basic mathematical skills, this leads to further decreased mathematical achievement in high school and college, and can lead to a decrease in societal and economical success for adults. As a person who's responsible for tracking and providing supports to a diverse range of learners, it's important for me to understand how formative assessments and feedback can best support mathematical proficiency in the classroom. When we examine the literature, we find that formative feedback through the use of formative assessments is a useful tool for teachers to provide students with the necessary guidance to help improve mathematical achievement. The timely feedback, identifying where students are lacking proficiency and in which direction their learning continues, helps enhance academic success. For students who were in remedial instruction, individualized and tailored assessments and feedback help improve mathematical proficiency when further assessments were administered. And exposing students to enhanced formative assessments and self-regulated learning, they also saw an increase in their mathematical performance and were much more successful in the classroom. And when we combine the structural practices with formative feedback, say for number rockets, a computerized program that instructs and then assesses mathematical proficiency, there was significant differences in mathematical proficiency scores between those who were exposed to the intervention and then those who were not. So there is evidence that formative assessments and feedback are essential to improving students' academic performance. However, there is not a consensus on how to best implement formative assessments and what they look like and how they progress and how to direct feedback to help students to be more successful. For the study, the experiential learning theory was used to best explain how students' experiences can help guide them to improved academic achievement. EOT is based on the concept that learning is an adaptive process, and engaging in one's environment and surroundings makes it much more cognitive. That occurs in four phases: concrete experiences, abstract conceptualization, reflective observation, and active experimentation. Students engage with experiences in concrete ideas, they engage in experimentation of those ideas, they review feedback and reflect on their learning, and after they reflect on their learning, they then actively experiment again, and the cycle just continues in the same process. The purpose of this study is to understand how specific feedback from a weekly formative assessment could improve overall mathematical proficiency. And it is hypothesized that when participants are exposed to the intervention, they'll improve their scores on the AMAP assessment. If there is statistical improvement, this could impact how educators implement formative assessments and provide feedback to their students. And for me, it could support how formative assessments are written and best supported in the general education classroom. The independent variable is the weekly formative assessments and feedback, and the dependent variable is the math performance as measured by a math assessment by FAST. Here's an example of the weekly formative assessment. The standard up on top with the 5 learning targets. And here's a couple examples of what the A math assessment may look like: multiple choice, fill in the blank, the fact that they have used the headphones, and so forth. A quasi-experimental non-equivalent control group design is used since the group's populations were not randomly assigned by the researcher. Also, the research design was used to address the effect of the intervention on classroom populations that were fairly similar. I started out with 61 total participants in an urban school district attending a Title I school. All participants placed in classrooms at random by the school guidance counselors. Here is the classroom demographics with the school population up top as of 2017. And then A, B, C, and D, the 4 classes that were used in the study. For the materials, students would use a standard Google Chromebook. And the copier is made on all copies made on a nondescript Xerox printed copy or fax. The intervention is a 10-question weekly form assessment over the learning progression of an underlying learning standard, followed by feedback at the beginning of the next week. The control group, however, will take a weekly exit ticket like they would have normally in the class about an individual target or standard, typically 1 to 4 questions long. The classes are 43 minutes long, with core standards being identified by the school district, and the experimental control classes use General Crow Math, published by McGraw-Hill in 2014. Pre-test, post-test, both experimental and control groups would take the 30-question AMAP assessment. For reliability, strong internal consistency with a coefficient of 0.95, and current validity comparing the 5th grade AMAP to the 5th grade Minnesota Comprehensive Assessment with a coefficient of 0.88. Groupings chosen at random by picking A, B, C, D out a hat. In this case, A and C are the experimental group, B and D were the control group. For the procedures for the experimental group, the weekly 10-question formative at the end of the week. Students would have the entire 43 minutes, class period of 43 minutes to complete the assessment. All instructions and questions are written out and presented verbally. Students would have the outside distractions monitored, and they were expected to not interact during the assessment. And when completed the assessment, students would find something quietly to do. Weekly feedbacks presented at the beginning of the next week for approximately 30 minutes. 10 to 15 of those minutes are used to review the assessment and the correct answers. The 10-15 minutes after that are used to answer questions, review the learning progression every week, and then practice any skills further. Any time left over is to prepare the students for what the instructional time will look like during the rest of the week. At the time the experimental group is working with intervention, the control group is just taking a weekly exit ticket over one learning target or standard. No individualized feedback provided the following week. For the procedures for the pre and post test, students begin with their Chromebook closed. The instructor has them open up the Chromebook, of course, and guide the students to the correct website. The instructor then checks the participants are on the correct website, that they have headphones. Participants would sign into the Fastword website using their first name and district ID number as the username and read one for password. At this point, the program provides instructions and tutorials, and the participants complete the assessment silently at their own pace, even though it takes about 20 to 30 minutes to have the entire class period. When they're completed, the participants would be expected to do something quietly. 2 independent sample t-tests were used to evaluate the pre and post tests. It's predicted that the experimental group would have higher scores than the control group. Both the pre-test and post-test did not show any significant differences before or after the intervention was implemented. Scores in the post-test did drop slightly, but not significantly to show major differences between either group. Please note that the number of participants declined to 55 total due to several participants refusing to take the post-test. Here is the independent samples t-test for the pre and post-test, and here is the pre-test post-test data for the mean standard scores. The results did not confirm the hypothesis and that the intervention would work and improve participants' standard-based scores on the AMAP assessment. Again, past research showed that when using forming assessments and feedback, it's an essential part of providing students a clear understanding of where their present skills currently lie and in what direction the learning will take place. But the results showed no significant impact considering that research, and the hypothesis was not confirmed. Again, students were exposed and had been exposed to written and verbal feedback about their learning progression and on a particular learning standard. But they still might have been confused about the direction of their overall learning and how all the learning standards were interconnected. And again, past research shows individualized assessments and feedback provided to students do increase mathematical achievement and proficiency. However, as a result of this study, that had no impact on their mathematical proficiency. And while previous research also concluded that making students better self-regulated learners improves the level of mathematical success, this study's results showed that students had not improved their mathematical proficiency scores. And the study exposed students to a continuous learning progress through the ELT by creating an environment where students were actively experimenting and adapting to feedback, but the results of the study failed to show significant improvements. A couple implications from this. There is an exposure to an enormous amount of mental fatigue for many students that cause stress and burnout by the end of the year. And also, students become less motivated and compliant as the school year progresses due to self-entitlement. They don't feel they have to output as much to get a specific grade or a score on something. To address those, students need to be supported with instruction that limits academic stress and burnout. Time away from instruction, time to cool down. However, it's regulated to help students not feel so stressed. And also, students need to understand that they need to reciprocate classroom responsibilities in any situation, in any class, to increase academic output and success. So this isn't just a math issue, it's across the board. For teachers, it must be considered that overwhelming the impact is how to support and administer student motivation through formative assessments. And as assessments become more embedded, teaching professionals must learn how to drive motivation using formative assessments. And if they can do that, addressing other concerns like poor parental involvement, climate culture, and other disruptions could be mitigated because the students are more motivated, understanding how formative assessments help drive their understanding. A couple limitations, whether and the length of the study need to be considered when looking into further research, or whether at the beginning of the study delayed the implementation of the intervention. And the length of the study provided way too many opportunities for students to be disrupted instructionally and for students to become non-compliant by the time of the post-test. Also, excessive amounts of academic stress is another limitation. Mental anguish on students really progress through an academic career and cause students not to be able to adapt to their environment. Further research should be conducted in the effects of mental fatigue on academic success, mathematical achievement, and the use of formative assessments. Also, the change delivery of SDI minutes moved from solely being the responsibility of a special education instructor to the responsibility of the general education teacher. Further research on who provides SDI services and then instruction impacts academic or mathematical achievement may be necessary. Another limitation is the complexity of mathematical attainment. And conducting research using the study's intervention at an earlier grade where students are attaining basic mathematical skills could be conducted to see if it's more effective for younger students. Students' prior experiences and predispositions and successes have an effect on later mathematical achievement. Other limitations are the amount of parental involvement, disruptions in students' daily lives, negative behavior in school culture, and both scheduled and unscheduled interruptions. And while some of these above limitations could be hard to collect data on, further research could be done on how daily disruptions affect academic and mathematical achievement. In conclusion, the hypothesis was not supported and was not confirmed. No significant improvements in participant score occurred. Continued research should be done to understand how to best implement the use of formal assessments and feedback so that it's best communicated to students about their learning experiences and to improve their mathematical achievement and even the achievement in other areas such as language arts, reading, or writing, social studies, or so forth. Thank you for listening to this presentation and have a wonderful night.